Welcome to our comprehensive guide on Lex programming. Lex can seem niche, but it's a powerful tool for anyone interested in compilers or programming languages. In this video, we'll break down the essential units of a Lex programming course. We'll start with the basics, get into the structure of Lex programs, and by the end, you'll be ready to build your own tools. Whether you're a coding novice or a seasoned pro, there's something here for everyone. Let's get started. So you want to speak the language of computers? Every time you run a program, your computer translates human-readable code into something it understands. That's where lexical analysis comes in. Think of it like reading a sentence. Your brain breaks it down into individual words, each with its own meaning. Lex is a tool that helps us build these lexical analyzers or scanners, taking raw code as input and churning out a stream of tokens. Efficient lexical analysis is key for creating fast and reliable compilers and interpreters.
Now, let's talk specs. In the world of Lex, everything revolves around defining tokens. Keywords like if, else, operators like plus, these are all examples of tokens. But how does Lex know what to look for? That's where patterns and regular expressions come in. Patterns are like blueprints, defining the structure of your tokens using regular expressions. For instance, you can define a pattern for an integer as a sequence of digits. Lex takes these rules and uses them to scan your code, identifying and classifying each part into its corresponding token. Alright, time to pop the hood and see how a Lex program is structured. Think of a Lex program as having three main sections: the definition section, the rules section, and the user code section. The definition section is where you set the stage, declaring variables and importing libraries. The rules section is where you define your tokens and their corresponding regular expressions. Finally, the user code section contains C code that gets executed when Lex finds a particular token. It's where you define what actions to perform based on the identified tokens.
So far, we've talked about what Lex does, but you might be wondering how it works its magic. Behind the scenes, Lex relies on finite state machines, FSMs. Imagine a flowchart with different states and transitions. You start at an initial state, and based on the input, you move to different states. Each state represents a specific point in the lexical analysis process. Lex takes your regular expressions and builds a super efficient FSM that can zip through your code, analyzing it token by token. It's like a well-oiled machine, optimized for speed and accuracy.
Now, Lex is great at breaking down code into tokens, but to build a complete compiler, you need a parser. That's where YACC comes in, yet another compiler. Think of Lex and YACC as a dynamic duo. Lex handles the lexical analysis, while YACC figures out the grammatical structure of your code. YACC works by defining a set of grammatical rules and uses the tokens generated by Lex to determine if your code follows those rules. If everything checks out, your code is syntactically correct. Together, Lex and YACC provide a powerful framework for building compilers and interpreters.
Now that you've got the basics down, let's explore some advanced techniques in Lex. One important aspect is optimization. You can optimize your Lex programs for faster lexical analysis. This might involve techniques like reducing the number of states in your FSM or using more efficient regular expressions. Another crucial aspect is error handling. You can equip your Lex program to gracefully handle errors and provide informative messages. Lex isn't just limited to compiler construction. It finds applications in text processing, data extraction, and building domain-specific languages. By mastering these advanced techniques, you can build even more robust and powerful tools.
Thanks for watching. If you found this guide helpful, don't forget to like, share, and subscribe for more programming tutorials. Remember, mastering Lex is a journey, and like any good tech, it takes practice and exploration. Keep coding, keep exploring, and I'll catch you in the next one.